All right, now for the second part of Target 1 video, it's the composite functions when the input is x. When you're finding the composite function itself, you're not actually dealing with a domain value of 5 or 2. It's the input of x. So let's go back to our problem that we started with. We got the answer 4 when we were finding f of g of -3. What we could have done, and I won't recommend, we could have found the composite function f of g of x first and then plugged in -3 into that function. Now what that means is this. F of g, let me change colors. F of g of x looks like that. All right, again, I'm going to go back to a number, okay? Go back to a number, an easy number. What if x was 3? What if x was 3? What would you do with 3? Square it, because g says square it. Okay, so you get 9. What would you do with the number 9? Plug it into f over here, 9 minus 5, you get 4, right? Okay. You're putting in x into g. What comes out? X squared. Remember this slide? When you put x in, the range value is 2x. When you put x into g, x squared comes out. So x squared becomes the input into f. What did we just say? We were going to at 9 when we put it into f, subtract 5, right? So we're going to take our input, x squared, put it into the function f, which says take it and subtract 5. When I put x squared right there, this becomes x squared minus 5. And that is your composite function. We should get the same answer 4. We should get the same answer 4 that we got earlier when we put in a -3. What is -3 squared? 9 minus 5. The answer is 4. So we could have found it that way. Now let's find another one. So I know 1 is not enough. You need to see this a few times. Let's find g of f of x. The order changed, right? So g of f of x. Let's start with a number, okay? Let's start with a number. What if the number, that x, what if it was a number, and that number was, make it easy, if that number was 8. 8. What would you do? If f of x, if that was an 8. You subtract 5 first, so you get 3, right? Take that 3 and square it, and the answer is 9, right? Same thing. Plugging an x into f, what do you get? When you put x into f, you get x minus 5. That's what you get. So you replace the input f of x to x minus 5. So that means you're going to take that thing and put it into g. And g says square it. Square it. Whatever it is, square it. So when you square it, you're squaring a binomial, which we've had on, what, 5 tests now with distractors? It's FOIL, F-O-I-L, and you get x squared minus 10x plus 25. All right, you try one, number 5. I'll pause the video. Try number 5. All right, so for number 5, we've tried it in class. The first thing to do is to take your function f, put an x in it. What comes out? When you put x into f of x, what comes out? X squared plus 2x does. So this problem becomes take x squared plus 2x and make it the input, make it the domain value of g. It's the thing you put into g. Now, what does g tell you to do? Whatever to any number you put into it. What does g tell you to do with that number? It tells you to take the number and triple it and add 5, right? G, the middle function, says triple that number and add 5. So as a template, Triple it, add 5, looks like that. Triple it, triple a parenthesis, and add 5. It's just you're going to triple an x squared plus 2x, which is distribute combine like terms. And when you distribute, there aren't any like terms. You get 3x squared plus 6x plus 5. All right, so that's the composite function when you're dealing with a variable as the input. So homework practices more of that concept.